Welcome to the tutorial on synthetic division. We're going to look at two examples today that deal with synthetic division and exactly what are roots and how would I look at them and how do we find factors of polynomials. The first one I wanted to go through today is just looking at synthetic division in its basic form. So in front of you, you have a polynomial, a fourth powered equation, and it's being divided by a linear equation. So you have 3x to the fourth minus 2x cubed plus x minus 4 divided by x minus 2. Synthetic division is a way of taking this expression and trying to make division possible and make it relatively easy. And so what we're going to do is we're going to look at a couple of things. The first thing we look at is I need to know the factor that I'm dividing by, because that factor will allow me to find the root that I want to test out. The ultimate question here is this a factor? Right? We're going to go through this example and we're going to divide x minus 2 into the above equation and see if I have a remainder or if I don't have a remainder. So the first thing we're going to do is take our factor. In this case, you have the factor here, and what we want to do is we want to take the factor and we want to find the root, and it's pretty obvious, you get the idea real quickly, that the root in this case is, when we set it equal to 0, you solve and we get x equals 2. So the root that we're going to test is x equals 2. The next part is to go ahead with my equation and set up our division problem. Okay, the things we're going to look at in order to do that with is we're going to divide by 2, and we're going to set it up using the values we have for coefficients for all of my x's. So we have x to the fourth, which was positive 3, then negative 2, then positive 1, and then negative 4. All right, and so it looks like this. What you notice is that I have a couple of numbers. I have a number that's not over here. So here we see a 0. Well, that 0 is not over here. But look what I have written on the top of that. We have right here, it's x to the fourth, x cubed, x squared, x, and our constant value. So if you go back over to our original equation, we don't have an x squared term here. And that's something you have to be very, very careful to do. If I have an x to the fourth power, that's my degree, the largest exponent in the equation, that means I'm going to have 5 terms. So 1, 2, 3, 4, and 5. You'll always have one more term than you do the number for your degree. That's because we have a missing x squared here. So when you have a missing value, you always put a placeholder for 0. All right, let's keep going. The first step in synthetic division is, once you've got it set up, you bring the first number and you just bring it down. The operation that you're going to apply is it's going to be a multiplication. You're going to take the number you're dividing by, multiply times 3. Now you're going to put it up here. So 2 times 3 equals 6. The next part would be to just add the two numbers that are on top of each other. So negative 2 plus 6 is positive 4. And I'm going to repeat this process, taking my 2 and multiplying times 4, putting it up here, adding, then taking 2, multiplying, put it up here, adding, and I'm going to continue that process until I get down to the end and I've used all my values. So this is what it looks like. So what we see is we've divided x minus 2 into this equation, and we have values left over here. Something that's important is the last number you get. I notice I've divided that, or I've separated that using this line. This number that we have is 30. This is what we call remainder. This is very similar to how you learned how to use long division when you were in grade school, in elementary school, and they taught you how to divide. You had a certain remainder. Well, here again, same idea. Okay, the next part is to rewrite our reduced equation that comes from these values right here. Okay, notice down at the bottom of the equation, the 3, the 4, the 8, the 17, and of course our 30. Notice where they went. 3x cubed, 4x squared, 8x, and 17. Now how do you get these values? Well, the values up here are the coefficients. How do I decide what x to use? You go back to your original equation. You take that number. The degree is going to be 1 less than the degree that you started with. And so since we started with a degree of 4, we're going to drop that to a degree of 3 and keep the process going down just like normal. I'm going to add the remainder over whatever I'm dividing by. Okay? In this case, I was dividing by x minus 2, or if you think about it this way, it's whatever is in this box, it's going to be x minus whatever's up here. And this is 2, so it's x minus 2. We write our remainder over that, and my answer to this problem is right here in the red box. 3x cubed plus 4x squared plus 8x plus 17 plus the 30 over x minus 2. One thing to note that I need you to remember is, what do we know about the remainder? The remainder is important. It tells us a few things. We have something called the factor theorem that talks about the remainder. It says that depending on what your remainder is, it tells me something about this value. If my remainder is exactly 0, then the number that I was dividing by, this value up here, is a root of the original polynomial. If I got something that's not 0, which I did in this case, right, we got 30. So that means that no, 2 is not a root of the original polynomial, because when I divided it, I had some leftover parts. Okay, that wasn't a factor. We tested the factor of 2, or the root 2, and it turned out to not be a root of the equation. In the next example, we're going to actually look at one that does have an exact root of the polynomial, and how do we look at that one? So we're going to take a little bit different approach to this. Here it says instructions of the problem are find all real roots, and I only give you this. And so you have x cubed minus 2x squared minus 11x plus 12. And I need to be able to factor that and to find out my roots. In this case, I can't actually find the roots by factoring or by quadratic formula, because this is not a quadratic, so I need a way to find those roots. Unfortunately, I didn't suggest a factor for you to divide by or give you a possibility for the roots. So you have to decide on a way to come up with those roots yourself. And this is how we do it. Real simple. For now, we're going to stick to the easier choices, easier possibilities, and you're going to look at the numbers in front and the back. Basically, we call them P and Q. We're going to let P be our constant term. We're going to let Q be our leading coefficient. Okay, it's not alphabetical. The P's at the end, the Q's up front. So think about backwards alphabetical order. And so the possibilities, because Q is 1, I'm really not going to worry about Q. Okay, so this is what it looks like. We have a possibility of taking all the different factors of 12. That's easy. So it's just 1 plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Something that you have, if you haven't figured this out yet, everything is always plus or minus. I just wrote down all the factors of 12. That's 1, 2, 3, 4, 6, and 12, and just plus or minus. So I actually have 12 different possible choices that I could use to try synthetic division with. Now that's kind of crazy, but I will not be trying all 12. There is a much easier way to do this, and we're going to kind of walk through that. All right, step number 2 would be to test out roots. I'm not sure which ones work, but the easy thing is to start with numbers that are easy. I'm going to start with number 1. Then I'll go to 2, and then maybe 3 or 4. I'll kind of work my way around and see what happens. So let's set up and do number 1. Okay, so when we're working with number 1, okay, or the first value, which is 1, I use my synthetic division. I notice over here it's 3, 2, 1, and 0 for degrees. So I didn't have to worry about adding any zeros to this equation. So that was nice. So I had a 1 here, I had a negative 2, a negative 11, and a positive 12. And you see those right over here. I'm going to bring that value down. I'm going to multiply 1 times 1 is 1, and then add the values together and keep that process going to the end. Notice you see here, I got 0. So first try, I got a root. So now there's 2 other roots I need to find. Rather than going back and trying this all over again from the beginning, what we can do is we can try different values and keep it going from where we are. So let's try this one. And notice what happened. I tried 2. So I started with 1. I figured, well, let's try 2. 2 brought the 1 down. I multiplied. 2 times 1 is 2. Add those together, I get positive 1. 2 times 1 is 2. And I add them together, and I got negative 10. That's not a root. Okay, so that one did not work out. So 2 is not going to work. So we're going to go ahead. We're just going to erase that and start over. So let's try I see I had a 12. I saw a negative 12, then I thought, well, you know, if I tried 2, I don't think I'm going to be able to get my numbers to become negative 12 yet, but 4 might work. All right, and if I didn't know that, I would have tried 3, and then I would have tried 4 next and kept the process going. And I tried 4, and it worked. So I brought the 1 down, multiplied through. Turns out that my remainder was 0 again. Remember, if the remainder is 0, it tells us, yes, this is a root. And I'm pretty much done. The last part's simple. If you take this part, when you only have 2 values, remember that's originally, we started off with an x to the 3rd power. Then it came down to x squared. Now this one would be just x, and that's my constant value, which would look like the reduced equation would look like this. We're going to set it equal to 0 and to solve. And it turns out my root turns out to be negative 3. So altogether we have roots of negative 3, 4, and 1. That's effectively how you use synthetic division when I have roots suggested to me and when I don't have roots suggested. All right? If you need to rewatch this, if you got questions, bring them with you to class.